Welcome to our tutorial. I'm Rafiul Hasan and I will talk to you about some concept for CSE 404 software engineering. The topic is object-oriented programming, and we have some things to discuss about object-oriented programming, and we will try to make it as simple as possible. First thing is my name now, and we should talk about something called inheritance. Inheritance can be defined as the process where one class acquires the properties of another. With the use of inheritance, the information is made manageable in hierarchical order. Inheritance refers to a feature of Java programming that lets you create classes and let you create classes that are derived from other classes. A class that based on another class inherits the other class, the class that is inherited in the parent class, the base class, or the superclass. So let's start with some coding, because if we can see some coding, it will always good for us to see. Now, so first, just write something. If we just bring some examples from Google, I think it will do more good, because just typing something will take us so long. So let's go for inheritance example. So let's check one thing. Just check this example. Just we can copy this and we can paste it here. Let's play new Java class. We should name it calculation. So David calculation, and then let's see. There's some problems in the class, and yeah, it is here. Now we can test it here, and we need another class. So we should create a new class. Which we will write as a name my calculator. And we should bring the code source over here. There are many examples. We won't go through this, but as we can see that we can call other things. Let's see. It adds some new projects. There's no other thing. So yeah, I don't think it's a good example to show you guys, but yeah, it will do. But we can look for another example, because typing a code in just like go for it. So just let's check it. Detected some error, but the whole concept of inheritance is based on how you can comply from the other class. You should do like for examples, we should bring some wait. What are some examples? Should have typed it, but well, let's say okay. Here we can see there is a class called parents. There's a public void p1 is a function, and then there is a print line where printing parent method, and there's another class child that extends parents, and then public void c1 is a function, and we are writing it system.println and child method. So we're using two functions in two classes. So let's create a child object. So child object, new child. So we created a new child object. Then what we did, we just create a C object, which is the name of our child object, and then we call the method of the parent class. But then we also call the method of the child class. Oh, sorry, the child class is here and the parent class is here. And then what we did, we see the some outputs. So what output we can see? We can see for this we have got child method, and for this we get parent method. So what happened here? We have created a child object, but as it extends the parent, as it inherits from the parent, then so this object can use the function of c1 also, and as well as his one c1. So this is another example. Let's just show you this, demonstrate this thing. Now there is a class called vehicle with string vehicle type, and the class car which extends vehicles. When car is a part of a class vehicle, but it's an own class. So there's a model type, and this show details. So vehicle type will be car, but is the string. This is accessing the vehicle class member. So now the model type will be sports. We could make another model type here for how for the vehicle, then it will be more easier. In the system type model type, there is a space and there is a vehicle type. And now in the main function, what we want to do, we want to create a new car, and we want to see the car show detail. So it will show sports car, but what if there are many inherited things? We should go and try putting some new class like trucks or cycles or bicycles. Okay. Now there's many types of inheritance. There's single inheritance, multi-level inheritance, and hierarchical inheritance. The simple inheritance, just one class just inherits another class. In the multi-level inheritance, one class inherits another class, and one other class inherits that class. And in hierarchical inheritance, one class can be inherited by two or more classes. Now, why multiple inheritance is not Java? Multiple inheritance doesn't support in Java because to remove ambiguity, and to provide more maintainable and clear design. So you can see there are to extend the two things, and when the third one comes and there's an ambiguity problem. And now one other thing, the super. The super keyword used to refer to immediately parent class of a class. In other words, super keyword is used to by a subclass whenever you need to be immediate super class. Okay. Now the parent thing, we can see super.name equal to parent. So we are just referring that super with super, we can refer in the name. Okay. So let's get back to our slide and see what we have next. Polymorphism. Polymorphism is an ability of an object to take on many forms. The most common use of polymorphism occurs when a parent class reference is used to refer to a child object. There are many types of polymorphism: ad hoc polymorphism, parametric polymorphism, subtyping, polytyping. Now, what we should do, we should search for polymorphism example, and just as it is not a coding tutorial video, so let's search for polymorphism in Java. Coding tonight. We have find this website very useful in our last thing. So I have myself spelled again. Study tonight. We will study tonight. Method overriding. Okay, so let's try this in C++, but whatever it is, the class concept is same, and just the input output method are different. So just look at some function overriding, which is called polymorphism. It means you will have same name for some function, and it will do just fine. Or we can have a look here if you want to stay on Java. Just do it. Okay, now method overriding. So when it occurs, when a method owns the subclass has no same name and type signature as a method in its superclass, then the method is known as overridden method. Method overriding is also referred to as runtime polymorphism. The key benefit of overriding ability: define the method that specifies a particular subclass. Okay, there's so much English, so much talking, but we just write into it and just know what it is. Now, there's a class animal. We created a class animal, and a public. We just created a public function void, which will not return anything, and it is a function name. And now we are just printing a function, printing a line system .out.println and generic animal editing. Now we created a dog, a class, another class which extends animal. We call it dog, and there's the same function. You see, the public void add. We have created another. So we are overwriting this function, and we're just printing dog ate meat. So what's happening here? When we're creating a dog class and calling for the eat function, there's a two eat function, one inside the dog class and one inside the animal class. The dog class eat function will override its parent's function eat, because that's what polymorphism do. It overrides its parent's function to do its own certain things. For example, there is something text generic animal eating. but the dog is not generic animal, it's dog, we know it, so we should print dog. So that's why we're overwriting our parents function to write our own message. Now you have to remember one thing, that static methods cannot be overwritten because a static method is bounded with class, while an inheritance method is bounded with object. Okay. Now, convenient return type. So there is animal my type, return new animal, and class dog extends animal, dog my type. So there is a new thing in Java 5 that just if we can override it, but just by changing its return type. So the first one is an animal return type, and second one is a dog return type, but the function remains same, and then it will do just fine. Now we should know something difference between overloading and overriding. Now, method overloading, what is it? The parameter must be different and the name must be same, and both name and parameter must be same in method. And method overloading, overload, that parameter must be different, and override, it must be the same because you should override it. That's why. Now, and the method overriding is the compile time polymorphism, and overriding is the runtime polymorphism. Increase readability of code, increase usability of code. So the code reads better when you overload the method, but the usability, the reusability, we are using the same code over and over again in different classes, the same function. This increase the usability of the course by method overloading. Overriding. Now, access specifiers can be changed. Access specifier must not be more restrictive than the original method. Access specifier can be changed, but in overriding, access specifier must be more restrictive than original methods. Now you can see overriding and overloading. There's a difference. In overloading, animal 8 and dog 8 string. So overloading, I have the same name of the function with different parameter, and overriding means animal eating and dog also ate. So the both doing the same thing. So we are overriding, experimenting, and overloading. We have also some topic to cover on overloading. We are covering it here. So in function overloading means you have the same function name with different parameters. So yeah, so that's quite good. Now let's move on to the slide. Method overloading. Method overloading is a feature that allows a class to have one or more methods having same name if the arguments lists are different. Yes, that's what we're talking about. Method overloading. We will have the same name but with different arguments. The arguments will not be the same. And method overloading is a feature that allows a class to have two or more methods having the same name if the argument list is different. In the last tutorial we discussed construct overloading. Construct overloading, we have seen it when we create a class and we just use it for overloading the constructor, then it calls construct overloading. Now let's move on. Overriding ability, we have already did it. Now access modifiers, let's talk about it. Let's see if we can. I'm using Google as it is not a programming based tutorial, because you can see that where you can find something. So access modifiers. So let's do it. Now we have different access modifiers in Java. There's a 4 access modifier control for classes, variable methods, and constructor. First one is default. So what a default does, a default has a scope only inside the same package. Now public is a scope which is visible everywhere. Public things like which you make public in real life, if you make something public, it is available to everyone, to hire everywhere. So yeah, the public scope is available everywhere. Now protected a scope within the package and also classes. For example, we saw some example below. For example, there's a variable of protected, and then pardon me. So it has access to its also classes. It is protected, but it is also available to its subclass. But in private, it is only available within its class, but not more than that. So now we can see a chart here that the public covers all of it, and the default covers the private class, protected class, and the child classes. And protected class can also be done in outside child package, but private should remain inside its own Java package. And there are some non-static access modifiers, which do not change the accessibility of variable method, but they do provide them special properties. So non-access modifiers are final, static, transient, synchronized, and volatile. Let's check. Final modifier is used to declare a field as final. An example, it prevents its content from being modified. Final field must be initialized when it's declared. So now, final, and then this float in class float, we can see the final integers max price is 19.99 and minimum price is 60.99, and we're just creating a display message which is final and which is void, and then max price is next price and this min price is min. Then a class also be declared as final, the declared cannot be inherited. So this, if we can create a class which is a final access modified, then it cannot be inherited. String class in Java is an example of final class. Yeah, the string class we use in Java is final class because whatever method declared in it we can inherit, but we cannot override the string function. Yeah, that's a good example. We don't want to override everything. You don't want to mess up your newly written code because you just made it available to other texts. So yeah, use finals. Now, static modifiers. Static modifiers are used to create class variables and class methods which can be accessed without instance of a class. Let's study how it works with the variable and the member function. Now, static variables are defined as a class member next to without any object in the class. Let's see. Class employee in static string company name, study tonight. So if we just make a company name study tonight, and then we can just use it in the thing, you can say that the one just in one company name, we're just doing it for everyone. So we're showing the name only, we're setting the name and just making it. So yeah, that's cool. And there are some differences we should talk about. Static variable and instance variable. That static variable represents common properties, and instance variables represent unique properties. Common means they have common things, and different unique means they have different properties. So that they're accessed using the class name and they exist using the object. So instance variable is focused on objects and static variable is focused on the class name. Now, get memory only once, it can get the memory only once and get new memory each time your object is created. So static variable can get the memory only one time, whereas the instance variable can get. Just let's check the sound is recording still. Yeah, it's still recording, so yeah, fine. Now static method. A method can be also declared static, like Static methods do not need instance of its class for being accessed. Main method is the most common example of static method. We can see in main that is declared static because it is called before any object of the class is created. So main must be called so that static function like this will also be called. Now question something: a non-static variable cannot be referred from a static content because it's not static. So yeah, just do transient modifiers. When a instance variable is declared as transient, the value doesn't persist of an object is saved. So regularly and wait. Now, synchronized modifier. When a method is synchronized, it can be accessed by only one thread at a time. We will discuss it in detail in thread. Volatile modifier tells the compiler that the volatile modifier can be changed unexpectedly by other parts of your other program. Volatile variables are used in case of multi-threading. So there are multi-thread in your programs and you want to use it in volatile modifier because you're smart ass and you're smart, you want to do it. So next time we'll go for there are two types of modifiers: Java active modifier, non-active modifier. Active modifier we will discuss private before protected public, and the public is within class. If you don't use any modifier, it is treated as default, and the default modifier accessible only within the package. Now the protected X modifier is stored in the package and outside the package but through inheritance only. The protected X modifier can be applied with the type member method and constructed can be applied on the class. So it is an interesting line. Key public access modifier is accessible everywhere. It has the widest scope among all the modifiers. Now, abstract class. We will just read it in the slide and then we will go for some examples. A class that is declared with abstract keyword is known as abstract class in Java. It can have abstract and non-abstract method. Abstraction is a process of hiding the implementation data and showing the functionality to the user. Another way, it shows the important things to the users and like the internal thing details. For example, sending SMS, we just type the message and we don't know how the message is being processed and how it's being sent and how it's being received. We just type it in and we just send it in. Now abstraction wants to focus on what the object does instead of how it does. So what it does before how it does. Sounds interesting, right? So let's see some examples. Abstract class in Java, and this is study tonight. So there's abstract class method. So we can take it. Abstract class. If a class contains any abstract method, then the class is declared as abstract class. An abstract class is never instantiated. It is used to provide abstraction. It means it will not show you what's happening there, but it will do your work and you will know which method it is. Now, the syntaxes, we should use the keyword abstract before the class or the method name. So for the abstract class, we should write abstract class and then class name. And for the method declared without anybody within an abstract class, I call abstract method. So abstract method should be inside abstract class. The method body will be defined by sub classes. Yes, that's an interesting thing. Abstract class as abstract method will be defined by its subclass, which means the other class that inherits from this class can define the abstract methods, but it can never be final static because it will be affected by its subclass. That's completely fine. So every class that will extend it will can use that abstract method. So abstract, then return type, then function name the same. So now let's check some abstract class examples. Abstract class A, and then abstract there is a function void call me, and then we are just creating another class B which extends abstract class A, and the function void call me now here extended, and there's a message which is it is just doing what the function will do, call me. So it's just defining what it will do in another subclass. The main class is not defining it, so we have this call me function intact, but you have a class which defines the other thing. So we can change the abstract class A, and then we have different things doing just by using the subclasses. So now this is the main function. We created a new class B object which we are calling smaller b, and then we're just calling the function b.calling, and our output is this is for b. Now fine. Just look at abstract class with concrete or normal method. Now just look at. So yeah, you can see in this abstract class A it is the same thing, that we have a normal method which is defined inside, and what it will is this printer method, but it is not has a keyword abstract, and we can also, as it is a subclass of it, we can also call this method, and we can do this. But first we need to remember something, that abstract classes are not interfaces, they're different. We will study this one or whatever they will study. An abstract class may or may not have an abstract method, but if any class have given a single abstract method, it must be declared abstract. So if you have an abstract method, then you must treat this class abstract. But an abstract class may or may not have been an abstract method. Now, abstract classes can have constructors, member variables, normal variables. Abstract classes are never instantiated. When you extend abstract class with abstract method, you must define the abstract method in the child class, or make the child class at least abstract, or you should use it. Now, what's the abstraction? So abstraction is the important feature of OOPS. It means hiding complexity. ABLACAS used to provide abstraction, although it does not provide 100% abstraction because it can also have concrete method. Let's see how abstract class is used to provide abstraction. Now let's see. There's a public abstract class vehicle where there is a public abstract void engine. Now, public class car extends variable, so there's a new class which is extending the variable the subclass, and we just overriding the function engine of the abstract function, the system car engine representing, and then we're just calling vehicle V. We are creating a new car subclass, and we have just shown the engine. Now here by casting instance of car type to variable reference, we are hiding the complexity of car type under vehicle. So vehicle, we don't need everything about the car, but we can still implement it by just ignoring the vehicle class. Now the vehicle reference can be used to provide implementation, but it will hide the actual implementation process. So when we should use it? Abstract method is usually declared when two or more subclasses are expected to do a similar thing in different ways through different implementation. This subclass extends the same abstract class and provide different implementation from the abstract method. Abstract classes are used to define generic types of behavior or at the top of the object-oriented programming class. We use subclasses to provide implementation details of the abstract class. No, that's fine. Yes, we're doing is good. Let's check for the sound again. Okay, now we're doing good. Now, what we have on our slides, we have no after class did 100% interface. A class that declares there is no after class. Number of argument lists could differ, and yeah, here we go. We have finished our video here. Hope you like it. See you in the next tutorial. Thank you for being with us, and see you then. Bye bye.